Okay, so let's get into this. We're doing a deep dive today into a really critical vulnerability in some of the most advanced AI.
Right. We're talking about multimodal large language models, or MLLMs.
And specifically, their inability to really, trust what they see. Researchers are calling it visual ungrounded hallucinations.
It all boils down to a fundamental bias, really. These models rely so heavily on their language priors.
So all the common sense they learned from reading, like billions of web pages.
Exactly. And that knowledge often overrides what they're actually seeing in a video, especially if that video shows something, well, something impossible.
And the source material had a perfect example of this. It's kind of amazing, actually. You show one of these top-tier models a video.
Uh-huh.
In the video, there's a girl standing on a small pile of rocks, and then suddenly the pile just grows, like it triples in size out of nowhere.
And a standard MLLM, even a really powerful one like GPT-4o, just ignores it. It defaults to common sense and says something like, the pile of rocks remains the same throughout the video.
Its brain knows rocks don't do that.
Right. But the new system we're looking at today, it gives the visually correct answer. It says,
Yeah.
the rocks multiply and grow into a much larger pile. It trusted its eyes.
That failure to see the impossible is what we're tackling. So how do you force an AI to see something it believes can't happen? I mean, do you just show it more impossible things?
That's precisely the idea. The
Mhm.
core problem is that these impossible videos are just so scarce in the real world. So the solution was to manufacture them.
To create them from scratch.
Yeah, using a framework called DualityForge. It uses these controllable diffusion-based video editing tools to just generate tons of high-quality counterfactual data.
So they're building this huge library of unreality. What kind of impossible stuff are we talking about here?
They broke it down into 3 levels to really challenge the model systematically. You've got your basic visual anomalies,
Pixel glitches, that sort of
the
thing.
distortions. Then you have semantic anomalies, where maybe an object just vanishes or gets swapped with something else. But the real challenge is the third category, common sense anomalies. This is where you get videos that just completely break the laws of physics.
And that's the real test, isn't it? Because an MLLM's internal textbook says lava cools and flows a certain way.
Right.
So if you show it a video where a lava stream just vanishes into thin air, it trusts the textbook, not the video.
Exactly. So DualityForge was used to create this massive data set called DualityVidQA. It's about 144,000 samples, all built on paired videos.
Paired, meaning you have the original normal video.
And the edited impossible version. And you ask the model the same question about both. It has to give different answers, which forces it to ground its logic in the visual evidence, not its prior knowledge.
So that gets us to the training itself. The data is one thing, but making the model learn is another. It's called a DNA train.
Duality normalized advantage training.
Yeah.
It's a 2-stage process. After some initial fine-tuning, it moves into a really critical reinforcement learning stage.
And what's special about that?
Well, it solves a balance problem. For an AI, normal real-world videos are easy. They generate a really strong, clear learning signal.
They fit the pattern it already knows.
But the counterfactual videos, the impossible ones, are much harder to process. And if you just train on both equally, the easy data just kind of dominates the process. The learning becomes unstable.
So you need a way to make the AI pay just as much attention to the hard stuff.
Precisely. They introduced this normalization technique that, in simple terms, acts like a dimmer switch. It turns down the learning impact of the easy, real videos.
Which forces the model to put equal effort into understanding the tricky, physics-defying ones.
It's it. And the results really back it up. This whole approach led to a 24% relative improvement in mitigating these hallucinations.
24%. That is a huge leap in making these systems more trustworthy, and it didn't just fix that one problem, right?
No, it also boosted performance on general video understanding tasks. So this isn't just a niche fix, it makes the model better overall. It's critical for things like robotics or verifying images.
So what's the big takeaway here, then?
I mean, it seems that sometimes the most effective way to get an AI to genuinely understand our reality is to challenge it with a very robust, very well-crafted, synthetic unreality.
By showing it things that can't happen, it learns to better see the things that do.
Yeah, and it really makes you wonder if we can fix this kind of deep-seated cognitive bias by showing an AI something impossible, what other weaknesses could we patch in the same way?